Hello, and welcome to a video about exponential problems dealing with half-life equations. Before we get to our problems 19 and 20 in the back of your packet, we first need to know what is the equation for a half-life problem. It's going to be A is equal to P times 1/2 T divided by H. In this case, A and P are the same as they've always been. A is your ending amount. P is your starting amount, or principal value. T is going to be time. And the new piece here is H, which is going to be for our half-life. Now, when dealing with half-life problems, it's usually dealing with some type of chemical or element that decays at a specific rate, and we look at how long does it take to have decay by half, or lose half of its volume or mass. I know those are not the exact same thing. I'm sorry for my sciencey people out there. But we're looking for that specific, how long does it take to lose half of its amount. So let's go through our problems and see what we need. Problem 19 here says, a particular radioactive chemical loses half of its radioactivity every 3 years. So it loses half of its radioactivity every 3 years. That tells me this is the half-life. Every 3 years, it loses half of its value. Now, if there is currently 100 grams, so that is our starting amount, or our p-value, of the chemical in the ground, how much will there be in 24 years? So that's giving us the time. So we have our p-value, our h-value, and our t-value. We're going to be looking for our ending amount, or our a-value. So when we set this up into our equation, we'll have A is equal to our starting amount of 100 grams times 1/2, it's always going to be times 1/2 for a half-life problem, to the power of 24 divided by 3. So if we were to simplify, this would be 100 times 1/2 to the power of 8. And then from here, you can plug this into your calculator. Normally, we're going to round to maybe the 4th decimal place for a chemical, but for here, we actually get kind of an exact answer around the 6th decimal place. So we'll say this is 0.390625, or almost 4/10 of a gram. So since this is a story problem, we need to finish with a sentence. So let's say in 24 years, there will be 0.390625, I know that's a long number, grams of the chemical left. Now, it doesn't name the chemical, so we could just say the chemical, and that's fine. But this is what it looks like to do a half-life problem. Let's do one more. The next problem reads, a particular radioactive chemical, so it starts the same, loses half of its radioactivity every 5 years. So now our half-life is 5 years. How much will there be in 25 years? So that's going to be our time. If there is currently 200 pounds of the substance. So this is our P, our principal or starting amount. So we're still going to take this information, plug it into our equation, and see what we get. So we're going to have A, or our end amount, is equal to 200 times 1/2 to the power of 25 divided by 5. Once we start simplifying this, we will have A, or all of this, is equal to 200 times 1/2 to the power of 5. And once we plug this into our calculator, we get something a little bit simpler than the previous problem. We're going to get 6.25. So to understand what this means, we need to write it in a sentence. So in 25 years, there will be 6.25 pounds, so remember the units are changing, of the chemical left. And there you have it. So hopefully half-life problems aren't too bad. If you have any questions, please let me know. I look forward to seeing you in class.